welcome everybody to the webcast today, Amazon Web Services for BI and Analytics. My name is Jeff Burke. I'm joined by my colleague, Deb Lee. We're both BI and Analytics consultants at Thorogood. We're working with our customers on a number of different cloud initiatives. We're joining today from the New York area, and we're welcoming quite a few people from around the world for today's webcast. In terms of the objectives for today, before we get into the technology aspects, we thought we'd review the value drivers for cloud BI and analytics to ground any technological consideration and the value that's going to be returned to the business. And then we'll introduce Amazon and eventually get to some demonstrations of some of the components here before we conclude with some considerations for the Amazon cloud and how you might go about adopting it. We have an agenda here to help support those objectives, with the first one being a brief introduction to Thorogood. Thorogood, we are BI and analytics specialists. We're a consulting company organized solely around BI and analytics. We are a global company ourselves. We do service quite a few different global customers around the world. In terms of the types of services we provide, our biggest practice area is a business-focused solution delivery. We also do some work around strategy and tool selection, and also provide some ongoing services for recurring data integration or support services as well. In terms of the types of customers we work for, this is a sample of our customers, and they generally fall into the kind of four data-rich sectors that you can see on the screen, although there are times that we do work for customers outside of these areas. And all of these customers are at various points on their cloud journeys. In terms of the technologies that we work with, we are an Amazon consulting partner, and that's the topic of today's webcast. But we are an independent company, and we work for kind of all the technologies that are relevant to our customers in this space. That's particularly important here because we partner and work with Amazon, the platform, for many of these tools, but we also work with a lot of the technologies that can be enabled through that platform as well. So now to get into the introduction to cloud and Amazon Web Services. Like I mentioned, we'll start with the key benefits. These benefits we brought out in a previous webcast, kind of an introductory to the cloud. In that webcast, we kind of go through each of these. I'm not going to enumerate each one of these here, but just to refresh our memories on what some of those value drivers are, and just to say that all of them are relevant as we talk about Amazon Web Service for BI and Analytics. Before we go deep into what the offerings are from Amazon, I thought I'd refresh us in terms of what a cloud services provider actually provides. So historically, a lot of organizations ran all their technology out of either wholly owned or leased data centers. And in that model, you're responsible for all elements of the technology, including the data center that it's in, as well as the kind of electricity and cooling to run the building. In the cloud, we have a number of different offerings from the cloud vendors, including Amazon. They're generally organized into kind of three levels of service. The first one here is infrastructure as a service, and that's where the cloud vendor, in this case Amazon, takes on effectively the virtualization platform. As a customer, you would be responsible for the virtual machines or servers, including things like the operating system, the software, the data that's running on those machines. The second level of service is called a platform as a service, and in this model, the vendor takes on a little bit more responsibility for actually running the underlying servers themselves. In this model, you're responsible for the kind of application and data that's associated with it, but less responsibility in terms of running the platform itself. And then in the last model here, software as a service, essentially as a consumer, you just benefit from the functionality, and effectively all the technology is being abstracted and handled by the vendor itself. and Amazon has offerings in each of these three areas, and we'll refer to it as we go through what they have to offer. So to kick off on Amazon itself here, I thought I'd answer the question kind of why Amazon? Like, why is it a topic for conversation? Why are we seeing it of interest in our customer base? One is there's quite a bit of usage of Amazon. A number of people are finding value in it. We also, at Thorogood, we get quite a bit of interest in the types of events around Amazon Web Services. The second aspect of it are some of the analyst reviews. So people like Gartner and Forrester ranking Amazon Web Services very highly in their respective analyst offerings and have been for some time. It has been getting more competitive, but Amazon still ranks as some of the best from an analyst perspective. And then lastly, we also see some familiar names on here from a BI and analytics perspective that are actually making use of Amazon Web Services for their offering. And that's interesting in kind of two scenarios or two cases. One is that they're pretty good use cases around kind of data and analytics workloads running on Amazon Web Services. The other aspect of it is if you are using or considering using some of those offerings that run on AWS, there may very well be synergies associated with using AWS for some of your own data or analytical needs. So in terms of how Amazon describes what some of their offerings are here, I've kind of listed quite a few of how they've categorized them here. And if you went out to this URL at the bottom of the screen and clicked on each of these icons, there's probably 6, 8, or 10 different offerings or services or products behind each one of these. So there's a lot that's out there. The good thing is that you don't necessarily need to know about every single one of them, certainly not to get started, and perhaps they may not be relevant to your business application. The important part here is that there are some that are kind of more relevant, some that will be less relevant, and some that will be kind of core to getting things up and running. We'll kind of highlight some of the ones that are most commonly used as part of BI and analytics applications, or the ones that are kind of finely tuned for those data and analytics workloads. So if we go into the list here, these are really highlights. It's not an exhaustive list, but some of the ones that kind of jump out and are particularly important for our applications. So the first one here are some of the core elements. So EC2 being the compute platform by which we run infrastructure as a service servers, and it's actually the platform that behind the scenes a lot of these Amazon components run on. S3 being essentially a file storage service that's very common for us to use to land files, either transferring them from a customer into the AWS cloud or even between Amazon services or components. Getting into the data storage aspects of it, there are a number of platform as a service offerings. The relational database service has the capability to host a variety of technologies, including things like SQL Server, Oracle, MySQL, etc. Redshift being the MPP data offering. So this might be comparable to some of the massively parallel processing engines like Teradata on-prem or Azure SQL Data Warehouse on the Microsoft side of things. EMR is their Hadoop as a service offering. As we get into some of the data transformation aspects, Glue is a relatively new data transformation engine. Data Pipeline helps us with the orchestration and scheduling of various activities. And this could be data transformation as well as other aspects that need to be scheduled. And then Data Migration Service, Deb will actually go deeper into this, but it allows us to move data either on a one-off basis or based on a recurring data integration need between on-prem and cloud components. And then lastly we have on here is visualization and analytics. One of the tools that Deb will pick up is QuickSight. that includes some aspects of business modeling, things like a calculation engine, as well as the ability to visualize analytics within the browser. We also have the Amazon machine learning offering listed here, which is a little bit more of a tool for sophisticated analytics for developers and integration into other applications. And as you'll see on here, these boxes say "and others" at the bottom. And really this goes back to that infrastructure as a service platform. We can run virtually any piece of software within the AWS cloud in conjunction with a lot of these tools. So if there isn't something that fits your need exactly on here, or there are particular tools that you're using as part of this, maybe Informatica for ETL, or another tool can always be used in conjunction with these components running on that EC2 platform. So with that, I'll hand it over to Deb to talk about the AWS offerings.
Thanks, Jeff. So as Jeff mentioned, we're now going to take a dive into the demo portion of our webcast, which will help us paint a picture of how we would look to leverage tools within the AWS landscape. For the purposes of this business case, I'm going to be playing the role of a member of the sales team that's working for a consumer packaged good company, specifically one that sells soup. We've received some external point-of-sale data from a third-party vendor, and we want to use it to drive further insights. However, we also have internal data that is aligned with our customer and region information, which we are currently storing on-premise and managing that data ourselves. Once we combine these, we want to look to actually perform analytics on them and perform some basic modeling so that we can share and distribute our reports to the rest of the team. So the aspects that I'll be focusing on in today's webcast are the migration of the data from my on-prem database, the storage and the actual database querying for all my data within the AWS cloud, and then the analytics component on top of it to drive business insights. So at a high level, the first part of the demo will be looking at migrating my internal data into the AWS environment so I can use it. The second demo will focus on storing and querying the external third-party data that I'll be receiving within AWS's database software. And then finally, I'll be looking at driving insights by using the visualization and calculation engine available in Amazon on top of that data set. So before I actually get into the AWS console, I just want to spend some time reviewing why I would perform a database migration in the first place. So if I'm manually maintaining my data on-premise, this is probably working for me very well. However, I'm not going to be able to fully enjoy the benefits of using the AWS platform until I have all of my data in there. To do this, I'll be using the Amazon Database Migration Service. And one of the key features of this service is that it supports homogeneous and heterogeneous database migration, meaning I can lift and shift my on-prem Oracle database to the AWS Oracle offering. But at the same time, if I'm using Microsoft SQL Server, for example, for my on-premise data, but I want to switch to using AWS's Redshift or RDS offering, it's just as easy to do both within the Amazon Migration Service tool. And these are just a few examples of some of the combos that are available. You can check out the other ones at the link shown here. Another important feature of this tool is that while I am actually migrating my data, I can minimize the downtime by leaving my on-premise database live so that at no point in time is the data unavailable for the business users. And like many of the other offerings within AWS, this is a secure and relatively inexpensive tool that is easy to get started with using. So just to circle back on why I would be doing this, I'm looking to migrate my internal data that I'm managing around my soup from my Microsoft SQL Server on-prem database to the AWS environment. So in order to do this, I need to sign in to the Amazon Web Services console. So this is the landing page of the AWS console. you'll see here that when you first log in, all of the AWS services are available. You can scroll through them and see them here, as Jeff alluded to earlier. So I'm interested in database migration. I can just type in database migration service, drop down. And the first thing that we'll see here is the dashboard page, which gives us a look at what's currently going on within my selected region, which is Oregon. You'll see here that for the purposes of this demo, I haven't set up many different tasks and endpoints. However, if I was using this tool on a recurring basis, I might have anywhere between 20 and 200 tasks running at any given point in time within my region. So the two key features that I want to highlight are the tasks and the endpoints. My tasks are essentially what I'm actually going to run in order to move the data. Tasks are created by defining a source and a target endpoint, which are defined in the endpoint service themselves. Oops, I meant to go back there. However, I've already predefined this task for the purpose of time for this demo. However, just to give you an idea of what my endpoints actually are, you can see here that my on-premise is my SQL Server database that I was talking about before, which is my source. My target is a Redshift cluster within my AWS environment. And if we go back to my test, I'm also going to show you the actual tables that I want to move. So some of you might be familiar with this interface, but within SQL Server Management Studio, I'm connected to my on-premise SQL Server, which contains my master data that I want to transfer over into the AWS environment. So you'll see here I have these tables. Now, to show you the target, I want to move my data into Redshift. So you'll notice here that I'm using a tool called Agility Workbench for Redshift, which is an open source tool approved by Amazon that is used for querying Redshift. And it actually has a pretty similar look and feel to SQL Server Management Studio. Even when I connect, I can specify my server name, my credentials, and then the database that I want to connect to, and it can save connections as well. I'm already connected, so you'll see here my soup database in my Redshift cluster only has one table in it, so it actually doesn't even have copies of the tables that I'm trying to move over around my product information. So if I go back to my Amazon console, I want to start running my task. So when I click Start and Resume, I have two options. I can either start the task or restart it. Essentially, I can start it. If it's an incremental load, it'll just pick up from where it left off before. So if I had to pause it for any reason, or if I only wanted to load the second half. However, I want to restart because I know that my tables don't even exist in my target database. So I'm going to start this task now. And you'll see here, there's a status bar that lets you know where your task is. So right now it's starting. And however, I can go over to my Redshift cluster and refresh my entity list. Nice. So we can see here that my tables are already starting to appear within my soup database. And I can even copy my select statement to my clipboard, just paste it, and execute this query. See that there's already data flowing through right as soon as I click the button. So I can refresh this again. There are a couple more tables that should appear. Great. Okay. So now I'm going to want to switch back. I can see that it's running. I can refresh the status again. Nice. My load completed. So another key component of this, I had mentioned security before, but for your endpoints, you can actually define the SSL mode that you want to use. So for the purpose of this demo, I haven't specified any, but AWS has that on almost any of its services that it offers. So I'm going to switch back to my slides now. So now that we've managed to get our data into the AWS environment, what's next? So I've managed to move my own data that I'm currently managing into AWS. However, I am receiving third-party files from the vendor that's selling me my sales data that I want to use with my own data. So I'm going to need to use two tools within AWS now. I need somewhere to store those files, and then I also need to put them into a database so I can also use them. So the first technology that I want to highlight is Amazon's S3, or Simple Storage Service, as Jeff had mentioned earlier. S3 can be thought of as a cost-effective file share, which can be used for backups, can be used to fed data lakes, or even for just storing the most business-critical data, so it's always available. And in this case, we're going to be using it to store the files that we're receiving from an external vendor. The second technology I'd like to highlight, which you have actually already seen through my Agility Workbench, is the Amazon Redshift tool. So this provides on-demand massive data warehouse capabilities using the massively parallel processing. And one of the key features of Redshift is that it allows you to essentially size up or down depending on how much you're using at a given point in time. So you'll really only be paying for what your business demands. To circle back to my business case, the point of using these two tools now is to use S3 to store my external file share information that I'm receiving on my soups, but then also to use it in parallel with the data that I've already moved into Redshift to perform data querying as well. So for this demo, we're mostly going to be within the Agility Workbench. So we'll see now that my soup database has most of my dimension information that I wanted to move in before. However, this fact information on the orders doesn't have any data in it. So just to show you that I'm not lying, I'm going to execute a query that's running a basic count star. Right, so I don't have any rows, any fact data. Now, to show you where I'm storing it, I'm going to use Agility's file shell S3 Explorer. So this is basically just a simple file explorer. There's really no limitations of what kind of files can be stored here. I'm only going to have access to the ones that my AWS account has access to, which is controlled through the Identity Access Management console in the cloud. My data that I'm interested in moving in to my Redshift cluster is this supplier purchase order data, which is actually a .gz file. So how do I get this into Redshift? I'm storing it currently in S3, but in order to use this data, I need to be able to get it into the actual database service. So you'll see here that from directly within the Agility Workbench tool, I can actually write a query that's going to copy into the table that I've already defined from my S3 file shell. So I actually have to specify credentials as well, which are over here to the side, defining the type of delimiter as well as the file type. So I'm going to execute this query. Great, says it completed successfully. So how do I know that the data was actually moved? I'm going to go back to my original count star query. It was 0 before. I'm going to execute this. Ah, nice. So you'll see I just moved about a little over 2.5 million rows into that table simply by performing this query. The caveat around this is that for the purposes of this demo, I only really needed to move this data into the table once. If you were looking to move data on a recurring needs basis, so say, for example, that vendor is going to send you GZ files every month, so you need to update your sales data every month, and you didn't want to have someone who manually is in charge of updating all of the fact tables. You could look to schedule those loads using one of the tools mentioned earlier, such as Pipeline. However, if you wanted to perform further ETL processes, for example, you could also look to use something such as the Glue service that we had talked about earlier, instead of performing query loads through Reginity. So, but now, however, you'll notice that in Redshift, I have all of the tables in one place to use. So for the next part of the demo, before I get into it, I want to give a brief overview of how I'm going to be performing analytics on this data. So Amazon QuickSight is AWS's cloud-based BI and analytics visualization tool. It can connect to both on-premise and cloud offerings, so you're not limited to just one or the other. And the key feature about QuickSight is that it leverages SPICE, which stands for Super Fast Parallel In-Memory Calculation Engine. And this tool basically gives you a data modeling layer within the AWS QuickSight sort of browser. And ultimately, the vision for SPICE is that it will be interoperable with other BI tools. So once you've created a SPICE data set and you've performed all of the necessary cleansing and revisions and calculations that you want on top of your data, in theory, you'd be able to hook it up to something like Tableau or ClickView or Power BI eventually. And because this is a cloud-based tool, you're quickly able to access it. All you need to do is log in through your internet browser, and you can share it out directly from the browser via email. And they also have an iPhone app for sending dashboards. So now that I have all my data in Redshift in the AWS environment, I want to now go into QuickSight and visualize it all together. So I'm going to go back to my console. And now if I go back to the home page and just search QuickSight, it's going to actually redirect me to a different tab. So the landing page within QuickSight has analyses and dashboards. The main difference between analyses and dashboards are that dashboards are meant to be the final version, or you can think of it as like the packaged, whatever you want to send out once you've created it, versus analyses provide more of a sandbox environment for working within your visualizations. So to quickly dive into SPICE right away, I'm going to click on New Analysis. So you'll see here that all the data sets that I have access to will show up. Some of these are Amazon's built-in data sets, and the ones with orange are actually already using SPICE. So I'm going to click on New Data Set just to show you how easy it is to connect to different kinds of underlying data sets. So I can directly upload CSVs, text files, Excel files. However, I can also connect directly to Salesforce, Athena, RDS, MySQL. So you can see here how powerful this can be. I can combine data from Salesforce with any kind of data that's sitting in my SQL server, for example, through this portal without having to write any queries to connect the two. So I'm going to show you how I would quickly connect to a Redshift cluster. So say, I'm still working with Soup. It's going to connect me to the tenant that I'm in. I want the Soup database, and then I need to provide the credentials. I'm going to validate that. Great. So now I'm just going to create this new data source. It's going to tell me to select which tables I want to work with first. However, you can always change this. I'm going to pick my purchase order header table. So I can either just select it or I can edit and preview the data. So when I first come into the SPICE environment, you'll see that query is the default selection for how I'm storing this data. However, I can choose to switch over to SPICE immediately or switch it back to query. You can see my selections on schema, preset, and I've only selected one table. So if I want to combine data, for example, if I want to join my calendar date or my product or region tables with my supplier data, you'll notice that this interface will look familiar to some of you who have seen Tableau before, but you essentially can specify the join type, so inner, left, right, outer, and QuickSight will provide you all the available fields that you can do the join on. So another feature is within the actual fields themselves, I can create calculated fields based on what I have in my environment. The language for creating calculated fields is pretty straightforward, and I'd say comparable to many of the other offerings, similar to Power BI, Tableau, and Qlik. And you essentially can create new calculated fields. One of the caveats for Spice is that it is limited to row over row calculations. So they haven't implemented a feature where you could do sum of all rows, like divided by the sum of all the other rows, for example, yet, but I would imagine that that feature will be in the pipeline as well. So I'm not actually going to load this data set right now for the sake of time. I'm going to now dive into a dashboard that I've already created before this demo, just to show you how I would use this as a business user to send to the rest of my team. So you can see here I've created a soup sales dashboard, and mostly just for the purposes of highlighting the types of visuals that we're using within QuickSight. You can see here I have a heat map. I have here a trend graph over time with functionality of scroll bars. If I go down, I can drill into or drill out of my different pivot table graphs. There we go. As well as KPIs and line graphs. So you'll notice along here on the side, I have all my fields available, as well as the visualization types available down here. The dashboard itself can include filters that apply to everything. However, you can also create filters on the visuals themselves. So you'll notice that here, if I click on Focus on Jones, it'll automatically generate this filter for me in the filter pane, which I can choose to then apply to the single visual or only one visual itself. I'm going to get rid of this filter because I don't actually want it. The suggested option here is similar to Power BI's sort of ask questions about your data feature. So QuickSight will try to figure out what it thinks you think is important and suggest visual types and data fields for you to view. The story feature is similar to Tableau's story feature, which is essentially could help you create sort of a presentation with more of a slide deck timeline view of it instead of actually having to go in and show different options. So once I've created this, I want to share it with the rest of my team. So up here you'll see the share feature, and I can create a new dashboard. So if I want to pre-package this so that no one can edit it once they have access to it, I'm going to create a dashboard and send it out. However, if there's someone that I work with closely who I actually want them to be able to add visualization, I would click Share Analysis. So I'm going to type in the name of my coworker, and it'll automatically detect it as long as that person is within my tenant. So they do need to have an AWS account. Can't just share it with anyone. And I'm going to set a permission as a co-owner because I think he should be able to go in and edit this dashboard. So now that I've clicked Share with him, he'll actually be able to go in, see the dashboard, and change it as well. So this was a quick look at Amazon QuickSight, and I think that it's essentially trying to give you an idea of how easy it is to go in and create a dashboard on top of all of the data modeling that you've already done to get it to this point. I'm going to switch back to my slides now and hand it back over to Jeff. And just a quick highlight is from looking at what we've done today, we've seen how I'm able to migrate my own on-premise company data that I'm managing on my soups and move it into the AWS environment. I'm also storing external third-party vendor information within the S3 file share, putting it all together within a Redshift cluster, and then using QuickSight to visualize and build a SPICE model on top of all that data.
Thanks, Deb. So just to touch on some of the considerations to get started here. And a lot of these relate to certainly Amazon as well as some of the other cloud providers. The first one that comes up pretty commonly is data integration. Historically, a lot of our data has originated within our systems on premise. With the kind of explosion of data, a lot of that data is now coming from third parties as well. And it's pretty typical that we'll work with our customers on a kind of hybrid data storage strategy so that we have some data on premise and some in the cloud, depending on what exactly the use case is and the vision for the use of that data. Next up here is data privacy and security, and security is really paramount for all of our customers. And there's some additional complexity around the cloud itself in terms of things like regulations within the countries or the cloud providers themselves, as well as sometimes within the data sets themselves in terms of where that data can be stored and what it can be used for. The third is around performance, and that very much has to do with the performance of our data loads and queries, and we have quite a few more tools available to us in the cloud than we would with just on-premise software, so in a lot of ways it's an opportunity. The thing that the cloud doesn't overcome or isn't a silver bullet for is the latency that would be required between geographically distinct locations. So for those of you that have considered that as part of your kind of your data strategy and where data is stored, that's still very relevant with the cloud consideration. And lastly, the administration of it, and the cloud does have some new aspects that need to be administered including things like shared tenants and bills from these vendors that may need to be allocated to different business units depending on their usage. So that's a consideration there, and I typically encourage our customers to think about the administration for the cloud in a new and fresh way, and not necessarily to manage it in the same way that data centers or technology is administered currently, really to take advantage of the value drivers of the cloud, things like responsiveness to the business groups. So in terms of the cloud coming up, as we speak about BI and analytics strategies with our customers, there are quite a few topics that come up in the context of cloud. One is as we start to look at tool selections and technology roadmaps, I'd say cloud is considered in every single one of them, really because of the value proposition that it has. And I think one of the questions that always comes up is people want to kind of future-proof their directions on these things. And while nobody can predict the future, I think a known aspect is that there will be quite a bit of innovation in this space. There has been, and we can expect that. One of the things that we advocate for is interoperability, so investing in technologies that work with other technologies so that you do have flexibility. So things like a number of the front-end BI and analytics tools working with the technology platform by which you're storing data in. Self-service has always been, or has been certainly in the last 5 to 10 years, a theme, and I'd argue that all of our users fall along a spectrum in terms of their capability and desire to work with data. I think some of the themes that have withstood the test of time is to define data structures that are consumable, depending on what the capability of the end user group is, whether it's a group that generally consumes reports or goes as far as doing some pretty sophisticated analytical things, as well as performance. That's always been a key driver of adoption, and we have quite a few more tools available to us in the cloud architectures. Third on here is enabling analytics, and this is an area that has quite a bit of momentum around it, and I would argue that the cloud capabilities are very suited to enabling the analytical use cases within our business. Oftentimes there are kind of compute-intensive workloads or a variety of tools that need to be used across just about every piece of data within the organization, and oftentimes quite a bit of data outside an organization. And the elasticity of the cloud is very valuable to fulfill this type of functionality. Then lastly, something that isn't necessarily a technical consideration, but is very much relevant as we talk about these strategies is the people aspect of things. So as with any new technology, there's kind of a learning curve associated with it. As people kind of learn these things, these skills are coveted on the marketplace. And there is a need to evolve some of the existing capabilities that we have within our technology teams and end user teams to make the most of the opportunity that exists here in the cloud. So with that, kind of how to get started on things, the one thing I thought I'd mention is the free version of Amazon here. So if you are just looking to kick the tires, the cloud in general has a pretty low barrier to entry in terms of getting started. You can make use of quite a few free components. We did for some aspects of the demonstrations today. Other aspects we did have to pay for to show them to everyone. But that's one way to get started. The other side of it is really to understand kind of what you're going for and identify your business objectives, whether it's a case similar to the one that Deb walked us through in terms of an opportunity with a large external source of data, whether it's enabling a data science group from an analytics perspective, or a very specific business question that'll drive value within your organization, is to start with that. And then we're also available to explore what that opportunity looks like in terms of the technical possibilities, and if there's something there to work towards that'll drive value for the businesses. And Deb and my contact information is on the last slide here. If there are any questions, feel free to send them through on the Q&A pane or jot down our email addresses here. We'd be happy to pick up with people after the event. That concludes our webcast today. Thank you, everyone.